Space, a realm where everything has an origin.
Mars' origin. Mars stands as one of the most studied worlds in the solar system. Its red surface, shaped by time and silence, preserves a long and complex history. Unlike Earth, where oceans and life constantly reshape the landscape, Mars holds its past in open view. Every crater, valley, and plain carries a record of processes that unfolded over billions of years. The story of Mars begins around 4.6 billion years ago, during the formation of the solar system. Dust and gas surrounding the young sun slowly gathered into larger bodies. Through repeated collisions and accumulation, these materials formed planetesimals, which eventually merged into planets. Mars formed in this early chaotic environment, growing into a rocky world smaller than Earth but similar in composition. In its earliest stage, Mars was a hot and active planet. Internal heat from formation and radioactive decay powered intense geological activity. A molten interior allowed heavy elements to sink toward the core, while lighter materials rose to form the crust. This process created a layered structure consisting of a metallic core, a rocky mantle, and a solid outer crust. As the surface cooled, volcanic activity became a dominant force. Massive volcanoes formed over time, releasing lava that spread across large regions. The most notable of these is Olympus Mons, the largest volcano in the solar system. It rises about 22 kilometers above the surrounding plains, a result of long-term eruptions in a region without plate movement. Unlike Earth, where tectonic plates shift and recycle the crust, Mars remained mostly stable, allowing volcanoes to grow to extreme sizes. The early atmosphere of Mars was thicker than it is today. It likely contained carbon dioxide, water vapor, and other gases released from volcanic eruptions. This atmosphere created conditions that allowed liquid water to exist on the surface. Evidence of this past water is visible in the form of valley networks, outflow channels, and mineral deposits that form in the presence of water. Large river-like channels cut through the Martian surface, indicating that water once flowed across the land. Some regions show branching patterns similar to river systems on Earth, suggesting rainfall or surface runoff. Other areas reveal signs of sudden flooding, where massive volumes of water carved deep channels in a short period. Lakes may have formed in low-lying areas, and there is evidence that parts of Mars could have supported long-lasting bodies of water. Sedimentary layers found in certain regions point to repeated deposition over time, a process commonly associated with standing water. These features suggest that early Mars was once a more dynamic and possibly habitable environment. However, this period of relative warmth and stability did not last. Over time, Mars began to lose its atmosphere. One of the key reasons for this change was its size. Being smaller than Earth, Mars had a weaker gravitational pull, making it harder to retain gases in its atmosphere. In addition, Mars lost its global magnetic field relatively early in its history. A magnetic field plays a critical role in protecting a planet's atmosphere from solar wind. Without this protection, charged particles from the sun can gradually strip away atmospheric gases. This process likely contributed to the thinning of the Martian atmosphere over billions of years. As the atmosphere became thinner, surface pressure dropped. Liquid water could no longer remain stable for long periods. It either froze into ice or evaporated into the atmosphere and was lost to space. The once active hydrological cycle came to an end, leaving behind dry channels and mineral traces as evidence of its past. The climate of Mars shifted dramatically. temperatures decreased, and the planet entered a cold and dry state. Today, the average surface temperature is around minus 60 degrees Celsius, with even colder conditions near the poles. The thin atmosphere, composed mostly of carbon dioxide, provides little insulation, allowing heat to escape easily. Despite these harsh conditions, Mars remains an active planet in certain ways. Dust storms are a common feature, ranging from small local events to planet-wide storms that can cover the entire surface. These storms are driven by temperature differences and atmospheric circulation. Fine dust particles are lifted into the air, sometimes remaining suspended for long periods. The surface of Mars is covered with iron oxide, which gives the planet its distinctive red color. This material formed through chemical reactions involving iron and oxygen, possibly influenced by past interactions with water. Over time, wind and dust movement have spread this material across the surface, creating a uniform appearance from a distance. Mars also features one of the largest canyon systems in the solar system, known as Valles Marineris. This vast network of valleys stretches over 4,000 kilometers and reaches depths of up to 7 kilometers. It is believed to have formed through a combination of tectonic activity and erosion. The scale of this structure highlights the powerful forces that once shaped the planet. The polar regions of Mars contain large ice caps made primarily of water ice, along with seasonal layers of carbon dioxide ice. During the winter, carbon dioxide from the atmosphere freezes at the poles, forming a temporary layer that later sublimates as temperatures rise. These cycles contribute to seasonal changes in the atmosphere. Beneath the surface, there is strong evidence that water still exists in frozen form. Subsurface ice deposits have been detected in various regions, and radar observations suggest the presence of layered ice structures. These hidden reserves provide insight into the planet's climatic history and may play a role in future exploration. The search for life on Mars has been a major focus of scientific research. While no direct evidence of life has been found, the presence of water in the past increases the possibility that simple microbial life could have existed at some point in the past. Current missions are designed to study the chemical composition of rocks and soil, looking for signs of past biological activity. Robotic explorers have played a key role in uncovering the history of Mars. Rovers and orbiters have mapped the surface, analyzed soil samples, and captured detailed images of geological features. These missions continue to expand understanding of the planet and provide valuable data for future exploration. One important discovery is the presence of organic molecules in Martian rocks. While these molecules are not proof of life, they are essential building blocks and indicate that the chemical conditions necessary for life may have existed at some point in the past. Another area of interest is methane gas detected in the Martian atmosphere. Methane can be produced through both biological and geological processes. Its presence, along with observed seasonal variations, has raised questions about its origin. Ongoing studies aim to determine whether it is linked to active geological processes or something more complex. Mars is also considered a potential destination for future human exploration. Its relatively close distance to Earth and availability of resources make it a candidate for long-term missions. Water ice, in particular, could be used for drinking, oxygen production, and fuel generation. However, the challenges are significant. The thin atmosphere provides little protection from radiation, and the low gravity can have long-term effects on the human body. Temperatures are extreme, and dust storms can disrupt equipment and reduce visibility. Any future mission will require advanced technology and careful planning. Efforts are already underway to prepare for human exploration.
Space agencies and private organizations are developing systems for transportation, habitation, and resource utilization. These plans include the use of local materials to support human presence, reducing the need to transport supplies from Earth. Mars continues to be a subject of deep scientific interest because it represents a planet that once had conditions similar to early Earth, but evolved in a very different way. By studying Mars, scientists gain insight into planetary evolution, climate change, and the factors that influence habitability. The surface of Mars, though quiet today, tells a story of transformation. From a warm and possibly wet environment to a cold and dry landscape, the planet has undergone dramatic changes. These changes are recorded in its rocks, valleys, and polar layers, waiting to be studied and understood. Each mission to Mars adds new information.